associated with eutrophication. You'll see that the southeastern portion of the United States, the reserves seem to be in the best shape as far as ecological resiliency goes. And so those are the general patterns. The next thing we looked at was the biophysical analysis. And what you're seeing on your screen is a map of the National Climate Data Center divisions of climate, or I should say the climate divisions that the NOAA's National Climate Data Center has been collecting both precipitation and air temperature data over the last 100 and 110 years or so. And so this was the long-term climate data set that we used in our overall assessment of climate analysis and the biophysical sensitivity work. We essentially mapped the reserves on the different climate divisions, and then we're able to get that data from the NCDC to look at the information that we're doing. And then the type of response variables that we are looking at each reserve that would be responding to changes in climate were from a biophysical data set that the reserves have been collecting over the last 15 to 20 years called the system-wide monitoring program water quality data set. Out of this data set, we looked at water temperature, specific conductivity, pH, dissolved oxygen, and turbidity. Essentially, the way the biophysical sensitivity scores were calculated was by testing a statistical relationship between the climate data and the response variables, which in this case are all the water quality variables. And I'm not going to go into a lot of detail on the methods. You can go into the report and sort of dig that out. But essentially what we were doing was we would take